Live in the human paradise. Breathe the pure air of heaven. Longevity, vitality, and a lifetime of bliss.
住在人间小天堂，呼吸天堂纯气，延寿长生，幸福一生。
You buy an air purifier for one simple reason. To clean the air. To get rid of pollutants.
Right.
But what happens when the very machine that's supposed to create purity starts drawing these dark, ugly streaks all over your clean walls? It's such a paradox.
It is. And it's a classic sign of a fundamental failure in the technology. We call it the black walls phenomenon. It's basically when the solution becomes a whole new kind of problem.
And that failure is exactly what we're diving into today. This is a deep dive based on some pretty specific engineering research, Master's Insight, #243, and related patent literature.
Right.
So our mission here is to get past just, how to clean the stain and really understand the chemistry, the entire electrical and chemical chain of events that turns invisible particles into stubborn wall art.
And for you listening, this isn't just about spotting a faulty machine. It's about understanding what happens when technology isn't fully contained. You're going to find out why your air cleaner might be secretly painting your house with chemically modified soot.
Okay, let's start with what you actually see. We're talking about these visible dark streaks, usually near the air purifier itself, or maybe along the ceiling.
Yeah, along the path of the airflow.
And they're not just smudges. They look like serious contamination. And you said this is mainly with older or maybe poorly designed electrostatic purifiers.
That's the key. Exclusively. The whole idea behind an electrostatic system is, honestly, it's elegant. You give airborne particles an electrical charge, and then you use collection plates with the opposite charge to pull them out of the air. They get trapped right inside the machine.
So the black walls are...
The black walls are the smoking gun. They proved the process failed. The charging part worked, but the capture part did not. Those ionized particles just escaped.
Yeah, so if they escaped and just settled like normal dust, you'd be able to just wipe them off. But they're so dark and stubborn. Are we talking about normal household dust here?
And that's where it gets really interesting. The source material is very clear on this. These deposits are absolutely not simple house dust. When you analyze what's actually on the walls, it's a chemically active complex. You've got fine carbon aerosols, things, soot mixed with oil mists from, say, cooking, and various organic vapors. But here's the kicker. All of them have been partially oxidized inside that purifier.
Partially oxidized. Okay, let's unpack that. Is it like a piece of wood? If you burn it completely, you just get ash?
Exactly.
But if you only burn it partway, you get that black, sticky, tar-like soot. Is that the right analogy?
That's a perfect analogy. The machine started a chemical change. It activated these pollutants, but it didn't finish the job by capturing them.
So instead, it just released them.
It released them as these highly reactive, sort of chemically primed particles that are now just ready to stick to anything and react even more.
So the purifier isn't just failing to clean. It's chemically weaponizing the pollution in the room, turning it into an adhesive.
That's a great way to put it. It's what makes the whole journey from the machine to the wall possible. And that journey happens in 3 distinct phases.
Okay, a 3-step mechanism. Let's break that down. How do these tiny, charged, sticky particles actually get across the room to find a wall?
So the first step is the most important one. It's charge retention.
Charge retention.
The aerosol particles get a persistent surface charge from the high voltage part of the purifier. If they manage to slip past the collection plates, they leave the machine still holding that charge.
But why does the charge stick around? I mean, if I get a static shock from a doorknob, that charge is gone instantly. Why don't these tiny particles just neutralize in the air?
Because air is actually a pretty bad conductor of electricity. It's an insulator.
Right.
So that electrical charge on these microscopic particles doesn't just disappear. You can hang on for minutes, sometimes even hours, as they just float around on the air currents in your home.
Wait, minutes or even hours? That's a really long time. So you have these activated, chemically primed particles just drifting, waiting for a place to land.
Yes. The entire house, your walls, your furniture, the ceiling, it all becomes a potential collection plate. It completely undoes the work of the purifier.
Which brings us to the second step, I assume.
Exactly. Step 2, electrostatic attraction. You now have these charged pollutants floating around. And just like magnets, they are drawn towards any surface that's grounded or has an opposite charge.
And your wall is a perfect target.
A perfect target. A typical painted wall is generally grounded or electrically neutral, so it's a huge, attractive surface for these charged aerosols.
But hold on, if the whole room has these particles, why do you see the worst streaks right near the unit? Why isn't the whole house just uniformly coated in a gray film?
That's a great question. It's about concentration and airflow. The cloud of charged particles is densest right as it exits the machine, so they're drawn to the nearest largest grounded surface.
Ah, okay.
The streaks show that initial path where the deposition is heaviest before the particles disperse more widely. They build up there first, starting as these very thin, sometimes barely visible gray films.
So that's the setup for the final stage. Step 3 must be where the real damage happens.
That's right. Step 3 is chemical interaction. This is what turns a faint film into a dark, adhesive nightmare.
Okay, so what's happening on the wall?
Once those particles are stuck to the surface, environmental factors take over and accelerate the process. The two main culprits are humidity in the air and, ironically, any ozone that was also created as a byproduct by the purifier itself.
Why do humidity and ozone have such a dramatic effect?
Remember, the particles were only partially oxidized. When they meet ozone, which is a very powerful oxidizer, or humidity, which can act as a catalyst,
Right.
they undergo more chemical reactions. The organic compounds can start linking together, a process called polymerization. This reaction creates a residue that is significantly darker, often black, and way, way more adhesive.
So it's chemically bonding to the paint? That explains why anyone who's tried to clean these streaks knows it's not like wiping off dust. It feels like you're scrubbing off permanent marker.
You're trying to break a chemical bond. The stain actually darkens over time because the chemistry is happening on your wall, not just in the machine.
So, okay, the black walls are a huge aesthetic problem, but what you're saying is it's really just a big red flag, a warning sign that the whole process is broken.
It's the single most crucial warning sign. That stain is undeniable proof that the system failed its primary job. And that failure points to two deeper, more serious problems. Either the unit is making way too much ozone, which is a health hazard, or it's failing to neutralize the charge before releasing the air.
You're trading one pollutant for another.
In either case, yes.
So we've diagnosed the problem. What's the solution? If someone listening has one of these or is thinking of buying one, what do they do?
Well, if you already see it happening, there are some short-term fixes. You can and should regularly clean or replace the collection plates. The dirtier the plates, the less effective they are, and the more particles escape.
But that's just managing symptoms.
Exactly. The fundamental solution, which all the research points to, is a shift to what are called closed path designs.
Closed path. Okay, what does that mean in practice?
It's a critical engineering principle. It means that the ionization and the capture must happen inside a completely sealed module, a controlled path. You can't let charged particles or excess ozone escape into your home environment.
So how do they guarantee that? How do they make sure everything is neutralized before the air comes out?
That's the difference between a cheap design and a safe one. A true closed path system has a secondary stage. After the collection plates, the air is forced through a charge neutralizer, maybe a low-voltage grid or a special carbon filter, right before the exhaust.
Yeah, fail-safe.
It's a fail-safe. It ensures that any particle that somehow slipped past the collectors loses its charge. It removes that magnetic force that pulls it to your walls.
That level of detail seems key. Our sources mention some modern systems like the Air 8-free maze purifier as an example of this principle.
Precisely. Systems designed that way can find all the reactive chemistry, the charging, the capture, the neutralization inside the box. They have built-in redundancy.
And the result is the air comes out clean and your room stays free of ozone odor and, of course, free of wall stains. It really reinforces that quote from the source material. Clean air should leave no trace, not even on the wall.
That has to be the benchmark for this kind of technology now.
This has been a really fascinating look at a chemical failure and an engineering success. So to recap this deep dive for you, the listener, we started with the irony of an air cleaner that stains your walls.
Right.
We learned that those stains aren't dust, but a complex cocktail of partially oxidized carbon, oil, and organic vapors.
The active stuff.
And finally, we saw that the real solution is a mandatory closed-path design, one that neutralizes any charge inside the machine, preventing those particles from ever making it to your walls.
And, we learned that the ideal of clean air is air that leaves no trace. We designed these things to solve one invisible problem, pollution, but we accidentally created a very visible one, the black walls. That failure to fully contain the process, it raises a much bigger question for you to think about. In a world that's relying more and more on these complex, invisible processes for cleanliness in our water, our food, our air, what other, subtle traces, other micropollutants or unintended byproducts might our technologies be creating that we just haven't learned to see or confine or even detect yet? It's something worth mulling over.
Air 8-free maze purifier. The world's first single-pass purifier. Combining ionization, electrostatics, and airflow maze. The machine replaces humans. To absorb and destroy every toxin, air enters the ion zone. Viruses and dust gain negative charge. They pass electrostatic filters. Then enter the toxbox maze. Aerosols dry on electrode walls, breaking down into CO2 and water. Inside the maze, air twists and strikes over 60 times. Each turn ends a toxin's life. Billions of particles in 0.1 second are fully purified. It releases Earth's purest air. The superheaven air quality. 8-free, dust-free, germ-free, toxin-free. Smoke-free, odor-free, heavy metal-free. Microplastic-free, aerosol-free. Not just an air machine. The only key to lifespan freedom. U.S. Patent No. 8268058B2.